Internet, welcome back. Today we're going to go ahead and look at the last page, the last part of the Unit 4 test review. Find y and the length of each side if the triangle ABC is isosceles with AB equals BC. Okay, so triangle ABC is isosceles, and we know that AB is equal to BC. The measure of AB is equal to the measure of BC, so that's awesome. So in the language of geometry, segment AB is congruent to segment BC, right? So put a tick mark here and a tick mark there, right? So that's AB, that's BC. What can I do with these two expressions here? Well, I can equal them to each other, right? So I do 4y is equal to, right? It's literally right there. Thank you very much. 4y is equal to 3y plus 2. So then, subtraction property of equality, y is equal to 2. And then my goal here is to figure out what AB is. And I know that y is equal to 2, right? And AB is right here. How long is the measure of AB? Right, well, currently AB is currently 4y, but we already know what y is equal to, right? We already know what y is equal to, so I'm just going to go ahead and evaluate. So 4 times 2, that's 8. So that's the measure of AB. To find the measure of BC, well, BC is currently 3y. Is currently 3y plus 2. And we know what y is, right? We already know what y is. So it's 3 times 2 plus 2. 3 times 2 is 6. 6 plus 2 is 8. So BC has to be 8. And I really didn't even have to do the math because these things are equal. So if I know what AB is, and given that AB is equal to BC, well, I really didn't need to show the work here. I just know it's 8. Okay, let's go ahead and figure out what AC is. AC is 3y, which is 3 times 2, which is 6. So that's the measure of AC, 6. Triangle FGH is an equilateral triangle. So that means that we're dealing with equal sides. Where FG is 3x plus 10, GH is 5x minus 8, and FH is equal to 4x plus 1. Find the length of FG. So go ahead and draw your triangle FGH. And when you're drawing your triangle, you're going to have to label it properly and in order, by the way. So it doesn't matter if you say FGH here, or I'm sorry, let me go ahead and rephrase it. If you write F, then you need to go ahead and go, I guess you could say clockwise, right? So here's F, then you write this clockwise, or you can actually do it counterclockwise. You can say F, G, H. But you can't say F and then put an H here. Actually, you technically can. I don't think it really matters. Let's see. G, F, H. Oh, it all works out, I think. It doesn't even matter. Okay, so just probably for the different shapes, it's just going to be a little weird. But F, G, H is what I'm going to go ahead and do. FG is what? 3x plus 10. GH is 5x minus 8. And FH is 4x plus 1. And since these are congruent because it's an equilateral triangle, I'm going to go ahead and put these tick marks here. Okay. So let's take a look at this, and I'm like, which expression should I use? It really doesn't matter which expression you use because you're going to get the same x. But I like to work with 5x minus 8 is equal to 4x plus 1. And the reason being is because, well, I can get x on the left-hand side very, very easily, and then I just add 8 both sides. So I get x is equal to 9, okay? So I have x, that's equal to 9. Got to figure out what FG is. FG is this. So FG is equal to 3x plus 10. Evaluate. You get 37, okay? That's it. That was really easy. Number 27, find the measure of each numbered angle. Angle 1, angle 2, angle 3. So here's angle 1, angle 2, and then where's angle 3? Angle 3 is right here. Okay. Do you agree that we have these two triangles? They're basically just kissing each other at this point. So I can just make a play. So I have this angle here and this angle here. I can figure out how long this angle is because these angles add up to 180 degrees, right? So if I just go ahead and do it, I'd have 180 minus 58 minus 39. Oops, I put that in my calculator wrong. Let me go ahead and redo that. 180 minus 58 minus 39. That's 83. Okay, so this here is 83. And I noticed that we got vertical angles involved, so this angle and this angle are congruent. So that means that the measuring angle 2 is 83 degrees. So this is 83 degrees. So that's awesome. Now look at this. I have this angle, and really what I can do here is just do the same thing what I did over here, because I already know what I know how long this angle is, I know how long that angle is, I just don't know what this angle is. So there's 180 minus 83 minus 35. So that is 62. So the measure angle 3 is 62 degrees. And then lastly, I gotta figure out what the measure angle 1 is. What I can do here, let me see if this works. I notice that this forms a linear pair, right? That forms a linear pair. So I just do 180 minus 83, which is gonna give you 97. Or, this is so important just in case you don't have something easy like this. This is considered the exterior angle, right? So angle 1 is the exterior angle. So remember, the exterior angle is equal to the two remote interior angles. And the remote interior angles are angles that are not adjacent to this angle here. This angle here. So I can do the measure angle 1 is equal to 39 plus 58. And is 39 plus 58 97? Yes. So that is 97 degrees. So there are really two ways to do that. But please keep in mind of the remote interior angles theorem. Number 28. Find the measure of angle ABC. Oh, there we go. This is dealing with the remote interior angles that we talked about. So it's just this. So I'm not going to rewrite this, but it's here. So the exterior angle in this case is 145, and the two remote interior angles are 95 and 2x. So I do 145 equals 145 is equal to 95 plus 2x. So 145 minus 95 is equal to 50. Equals 2x, so x is equal to 25. And it's really asking to figure out what the angle ABC is. So ABC. So it's really asking what is the angle ABC, which measure angle ABC is currently 2x. So then if I replace, that's 2 times 25, that's 50 degrees. So the answer is 50 degrees. Okay. Number 29, list the angles and sides in order from smallest to smallest to largest. So you're really just naming. You're really naming. No numbers should be in your answers. Okay, so really I want you to understand this. Like, if you draw, the smaller the angle, then the side opposite to the angle here. So this is the angle, the side opposite to the angle that you draw is going to be small. right? And then if you draw a big angle, an obtuse angle, then the side is going to be big. Okay, that's really the whole concept behind it. Like, we're talking about theory stuff, right? So talking about the sides, these are the sides. Okay, so these are the sides, and then the angles, well, these little things right there. All right, so let's go ahead and just take a look at the picture. I'm gonna go ahead and fill in the blanks here. So that's 60, 54, and then this should be 66. Okay, that's 66, because 66 plus 54 plus 60, that's 180, because when you add all the angles up, they should equal to 180 degrees. So then let's go ahead and just determine the sides. Or actually, let's do the angles, because that's going to be easy. So what's the smallest angle? The smallest angle has to be 54. 54, so that is associated to angle T. The next smallest angle is 60, so angle S, and lastly angle R, okay, because that's the largest. And now, like I said, the bigger the angle, then the side opposite to that angle is also going to be big, right? Keep that in mind, because now we're going to go ahead and determine the sides from smallest to largest. So here is angle T, which is 54. Okay, and it's associated to segment RS. So segment RS is the smallest side. And then the second smallest should be, you know, segment RT, because angle S is the second, or medium, I guess, the second smallest angle. So therefore, this is the second smallest side. So segment RT. And then lastly, angle R is the bigger angle, therefore our segment ST is the biggest out of all. Okay, segment ST is the largest side of them all. Okay, so that's basically it, and I just completed the review, so that's awesome. So good luck with your studying. I will see you for Unit 5. Bye bye.